Good evening to all of you, and welcome to the seventh and the last day of this 1 week faculty development program on research methodology and data analysis. And this is the workshop that is organized by Kolkata Bidhannagar Society for Academic Advancement, jointly with Nowgong College, Assam, Jhargram Raj College, Jhargram, and Domkal Girls College, Murshidabad. Unlike other days, today we have one technical session, and that would be addressed by Dr. Chitradipa Chakraborty. And after the session gets over, we have an evaluation test to be conducted for you, and that will be followed by a valedictory session. So I now request Lopamudra Bhattacharjee Madam to introduce our first resource person for the first technical session and to take charge of this session. Madam, please.
Thank you, sir. It is my honor and privilege to introduce before all Dr. Chitradipa Chakraborty. At present, Dr.
You are not
Chitradipa...
audible, madam.
Sir? Hello? Hello? Am I audible?
Hi, yes.
Am I audible?
Yes.
Okay.
You are unmuted, but voice is not coming to us.
Am I audible now, sir? Shall I continue, sir?
No voice.
Yes, continue.
Okay. At present, Dr. Chitradipa Chakraborty is an assistant professor.
Not audible.
Abhijit sir, Abhijit sir is telling I'm not audible.
Okay.
Okay. At present, Dr. Chitradipa Chakraborty is an assistant professor in statistics under the Faculty of Commerce and Management, St. Xavier's University, Kolkata. She completed her BSc in Statistics from St. Xavier's College, Kolkata, and MSc in Statistics from IIT Kanpur as an Inspire Scholarship holder for 5 years based on the result in 12th standard. She was awarded PhD degree in Statistics under the same institute in Kanpur. Then she pursued postdoctoral research as visiting scientist, first at Indian Statistical Institute, Bangalore Center, and then at Indian Statistical Institute, Kolkata. During her research work, she presented papers in 2 international conferences and attended 1 more international conference. She has also participated at a workshop at Institute of Mathematical Sciences, National University of Singapore, where she did a poster presentation as well. She took part in 1 summer internship on official statistical system at Data Processing Division in National Sample Survey Office, Ministry of Statistics and Programming Implementation. Her areas of specialization and research are non-parametric inference, regression problems, robust statistical methods, estimation, measurement error models, Bayesian statistics, and comparison of distributions in infinite dimensional spaces. She has a few publications to her credit. So it is now my honor to introduce before all Dr. Chitradipa, and over to you, ma'am.
Good evening, everyone. Am I audible properly?
Yes, ma'am.
Okay. Thank you, Lopamudra, for this wonderful introduction. So, sincere thanks to the organizing team of this 1-week faculty development program, Kolkata Bidhannagar Society for Academic Advancement, Nowgong College Autonomous Assam, Jhargram Raj College, Jhargram, and Domkal Girls College, Murshidabad, and especially Professor Pema Lama sir for inviting me to deliver today's session. It is my honor to be a part of this faculty development program. So my today's session is about so I'm sharing the screen. Is it visible?
Not yet, ma'am. Yeah, now it's visible.
Okay, thank you. So today's session is about simple use of sampling in research. So in research, one of our main objective is to obtain information about the population. So what is population? Population is the whole of any finite or infinite collection of elements. So population also can be known as universe, but there is a thin line difference between the universe and population. Universe can be considered as the vast concept than population. So we can say that universe is the superset of population. Anyway, most of the cases we consider them as same. So suppose if we consider one research problem that a researcher would like to study the adverse side effects of a drug on the country's population. Now, country's population, if we take India, that's almost 140 crores population. So it's not, is it possible to use the complete enumeration or we prefer sampling? So what is the difference between the complete enumeration and the sampling? So complete enumeration is basically the survey on the entire population. Suppose the population is 140 crores, so we'll study that 140 crores individual and then give some result. So if we study this vast population, then that should be very expensive, more time consuming, and as we are dealing with this vast population size, so that the computation and data collection should be less accurate. Now, on the other hand, if we consider sampling, then we just do the survey on the part of that population that would be the representative of the population. As the number of the size is small, so that would be less expensive, less time consuming, and more accurate. So except some special cases, the researcher will prefer sampling over complete enumeration. So when we start with sampling, then first we have to determine the sampling frame, a complete list of elements comprising the population from which a sample is to be selected. Now, second questions come to any researcher's mind, that which sampling technique should be considered. So this is the sampling design process. So first we have to define the population, then determine the sampling frame, then select the sampling technique. So we are at the third stage now. So the most important decision about the choice of the sampling technique is whether to use the probability sampling or non-probability, because sampling technique is of two types, probability and non-probability. So we can just study the basic comparison of these two sampling. So probability sampling, basically as the name has, the probability sampling relies on probability or chance. And non-probability sampling relies on the judgment or convenience of the researcher. Now, basis of selection, probability of sampling, we can select the random elements, and in non-probability sampling, that will be an arbitrary choice. Now, for probability sampling, or in the probability sampling, for each individual, there is a pre-assigned probability of being selected in the sample, and that is known to us. But for non-probability, that is not specified and unknown. This is completely dependent on the researcher. So basically, the probability sampling, the research will be conclusive and non-probabilistic, that is exploratory. Result will be unbiased. For non-probabilistic, that will be biased because the researcher, the judgment of the researcher, this is dependent on the judgment of the researcher. So that is biased values or biased result. And for probability, we can test the hypothesis, but for non-probability, it's not possible. We can generate the hypothesis. Now, so that means, now there are two types of sampling techniques that I have already said, that probability sampling techniques and the non-probability sampling techniques. In probability sampling technique, we have four types: simple random sampling, systematic sampling, stratified, and cluster. Other sampling techniques we can say about the multi-stage or multi-phase, but these are not very useful in research most of the times. So we just focus on these first four sampling techniques. And for non-probability, there are also four sampling techniques: convenience, judgmental or purposive, quota and snowball. So first we consider the simple random sampling. So you can see the picture here. We have 15 individuals. Suppose this is our population size, and we want to select a sample of size 5 using the simple random sampling. And simple random sampling, this is one of the best probability sampling techniques that helps in saving time and resources. And it is a reliable method of obtaining information where every single member of the population is chosen randomly merely by chance. Each individual has the same probability of being chosen to be a part of a sample. So now if we have the 15 population size and we want to select 5 from them using simple random sampling. So first thing that we have to do, we have to assign serial numbers to the elements in the population from 1 to n. In our case, suppose 15, 1 to 15. Now choose an appropriate number of digits. Suppose if n equals to 900, that would be 3. For our case, suppose 15, so that would be 2. From any point in the random number table. So random number table, basically we have some numbers, some digits of the clustering numbers, and we will select 2 numbers at a time. And if that particular number is less than or equal to n, that will be our first element. If that is greater than n, we'll delete that or we'll discard that one. This is how we'll move to the next random number. We can go any direction, vertically, horizontally, or diagonally in any other direction. And we'll discard 0 value. If we get the duplicate numbers, we'll discard that one also and the numbers greater than n. This is how we continue the process until we'll select n different numbers. In our case, 5 different numbers between 1 to 15. So in this case, we can see that random numbers we have selected 1, 4, 8, 9, and 11. So this will be our sample. Now, next one, systematic sampling. So researchers use this sampling to choose the sample of a population at regular intervals. And this regular interval is known as sampling interval. It requires the selection of a starting point for the sample and the sample size that can be repeated at regular interval. And this type of sampling method has a predefined range, and hence the sampling technique is least time consuming. So now you can see here there is also 15 individuals and we want to select 5 from them. Now what is the process? As we have discussed for the simple random sampling, here also we'll assign serial numbers to the elements in the population from 1 to 15. Now determine the sampling interval k, that is equals to population size divided by sample size. So in our case, population size is 15 and the sample size is 5. So k, the sampling interval, will be 3. Now select a random number r between 1 to k. So we'll select between 1 to 3. So that can be 1, that can be 2, that can be 3. Now in systematic sampling, the elements to be included are r plus k. That means first, suppose the first random number, that is 1. So 1, next selection will be 1 plus 3, 4, 4 plus 3, 7, 7 plus 3, 10, 10 plus 3, 13. Suppose a random number, that is 2, like here, 2. So 2, after that, the selection will be 5, 5 plus 3, 8, 8 plus 3, 11, 11 plus 3, 14. Similarly, if 3, 3, 6, 9, 12, 15. This is how we'll select the sample in systematic sampling. Now, suppose if k is fraction, suppose instead of 15, suppose n is 14. So n by n, that k is not a whole number, but will round to the nearest whole number, that is 3. But here, the selection procedure is little different. Select a random number r from 1 to n. That means from 1 to 15. So it can be 1, 2, 3, 4, 5, 11, 12, 13, 14, 15, anything. Now then select, suppose the random number is 3. Now 3, then the next selection will be 6. 6 plus 3, 9. 9 plus 3, 12. 12 plus 3, 15. But the population size is 14. So we can't have any 15th element. So what will we do? We just go back to the first element. So that means our sample will be 3, 6, 9, 12, and 1. Similarly, suppose the random number is 4. So 4, 7, 10, 13, 16, but there is no 16th element. So we'll go back to the second element. So 4, 7, 10, 13, and 2. This is our sample. This is how systematic sampling works. Now the next one, that is stratified sampling. So when the stratified sampling used, so this is basically the simple random sampling, but using some strata. So suppose in a population, there is some male participant and some female participants. Okay. And in the population, suppose there's the 15 population size, there are 6 females and 9 males. So we can see 2:3 ratio between female and male. Now, if we select a sample, and we can see in that sample that the ratio is 4:1 or 1:4 or 3:2 between female and male. So those samples we can't consider as the representative of the population. That's a problem because sample is the representative of the population. Otherwise, we can't use that sample. So to get that type of sample, we need to stratify the data. So how? This probability sampling in which the population is divided into smaller subpopulations according to one or more common attributes. In our case, suppose we use the sex. It can be age, it can be income, it can be level of education, anything. Now a sample is drawn from each of that subpopulation independently. So select the stratification variable. In our case, we can select using the sex, divide the whole population into k subpopulations, suppose 2 subpopulation, the first 2 strata and the singular is stratum. So the first stratum having n1 unit, that is 6, second stratum has 9 units, n2 is 9. Based on the stratification variable, assign each element of the population to one of the k strata, determine the sample size using proportional or optimum allocation rule. There are different types of rule. We'll basically select the proportional allocation rule, suppose n by capital N into ni. So suppose from the first stratum, we'll select 2 and from the second, we'll select 3. Then we have the total 5 sample. From ith stratum, select a simple random sample of size ni. Now the last probability sampling, that is cluster sampling. This is a method of probability sampling that is often used to study large populations, particularly those that are widely geographically dispersed. So there is a heterogeneous data. In cluster sampling, a population is divided into smaller groups, that is known as clusters, and then the required number of clusters is selected randomly, either by equal or unequal probabilities of selection. So in cluster sampling, ideally, clusters should be formed so that within a given cluster, the elements are heterogeneous as much as possible so that that can be the representative of the population. So what is the basic difference? So here we can say divide the whole population into C clusters. Here we have 5 clusters. Each cluster should have a similar distribution of characteristics as the distribution of the population as a whole. There not be any overlap between the cluster, and select the required number of clusters randomly to form a sample, and all the individuals are taken from randomly selected samples. So we have selected 2 clusters, second and the fourth, and all elements from that cluster will select as the sample. So what is the basic difference between the stratified and the cluster? So in stratified, we'll divide the subpopulation like the groups are homogeneous, the homogeneous segments in stratified. But cluster, the groups are heterogeneous within. So we can say the stratified groups, the strata, are homogeneous within the group and heterogeneous between the group, but the cluster, they are homogeneous between the groups but heterogeneous within the group. And the stratified, the strata, are imposed by the researchers, and the cluster that is naturally occurred. So this is the basic difference between the stratified and the cluster sampling. So now we can take this as a graphical illustration. I've already discussed this type of thing. Suppose we have population of 25 elements and we have to select 5 from them. Now A, B, C, D, E, 5 groups we can already select and they can be considered as strata or cluster. So if we consider the simple random sampling, then select the 5 random numbers, 3, 7, 9, 16, 24. These are the simple random sampling. Systematic, suppose 2, and the sampling interval will be 25 by 5, 5. So the sampling interval will be 5. Suppose the random number is 2, then next one will be 7, 12, 17, 22. And stratified, we have 5 strata. So from each strata, we'll select 1 sample. And for cluster, first we select 3 cluster, B, D, E. Then from those cluster, we can select all those elements, but it is a 2-stage, multi-stage, because here we have in the multi-stage cluster sampling, rather than collect data from every single unit of the selected cluster, we can again randomly select some individual from that selected cluster. So here, suppose from the selected clusters, from B we'll select 7th individual, from D and E, 18th, 20, 21st, and 23rd. So this is the selection. So after discussing the probability sampling, so we have 4 different types of probability sampling, but why we need the non-probability sampling? So in reality, sometimes, so when we use the probability sampling, then we need the definition of the list of the population and the sampling frame. Otherwise, we can't use the probability sampling. And in reality, this is the problem to obtain the reliable list of the desired population or the sampling frame. So that's why many cases in reality, it is difficult to use the probability sampling, and then we need the non-probability sampling. Now we have 4 types of non-probability sampling. First one is convenience sampling. So as we have the name, so this is based on the researcher's convenience. This refers to selecting sample based on convenience. Thus, a study may include elements which are conveniently located or willing to cooperate in offering the necessary data. This non-probability sampling method is used when there are time and cost limitations in collecting data. In situations where there are resource limitations, such as the initial stages of research, the convenience sampling is used. For example, startups and NGOs usually conduct convenience sampling to collect the data or the distributing the leaflets. Now, next one is purposive. I'm coming to the comparison between these two later. So, judgmental and purposive. This sample is used when the choice of the individual elements of a sample entirely depends on the judgment of the researcher. That the elements constituting the sample are chosen not according to some scientific procedure, but according to the personal choice or judgment of the researcher. For example, so first, what is the difference between the convenience and the purposive? So you can say these two samplings are equal. They're same. No, they're not same. So suppose a researcher wants to study, or for a study, he or she wants to interview the nurses about the experience during the COVID-19 pandemic. Now, yes, is there any problem? So, yes. So then if we use the convenience sampling, so what the researcher can do, he or she can interview any bachelor nurse of the public sectors, public hospitals. That's for her convenience. But if we use a purposive sampling for that interview study, then he or she will choose the nurses who are experienced and from public and private sectors. So there is a strong reason behind that selection, not that this is the convenient to me and I'm selecting that now. So for purposive sampling or judgmental sampling, there is a specific reason behind that selection. So this is the basic difference between convenience and the purposive sampling. For example, of purposive sampling, to determine the patterns of use of the social media by global IT consulting companies based in the US, rather than applying random sampling and choosing subjects who may not be available, the researcher can use purposive sampling to choose IT companies whose availability and attitude are compatible with the study. Next is quota sampling. In this sampling, the selection of members in this sampling technique happens based on a preset standard. In this case, as a sample is formed based on specific attributes, the created sample will have the same qualities found in the total population. So basically, researcher can apply quotas based on the sampling frame, and these quotas are dependent. The researcher will divide the population in quotas depending on their some choice, and not necessarily that quotas will be equal. This is not necessary that the researcher will divide the quotas equally. As per his or her need, he or she can divide the quotas. And we can just say this is the non-probability version of the stratified sampling. For example, a researcher wants to study, suppose, individual about what smartphone brand they prefer. So the researcher considered the sample size of 500 respondents and is interested in serving 10 states. So he can divide those in different quotas and then find the sample. Now the next one, snowball sampling. This sampling is used when the population has some rare characteristic. So this technique is used when the population being sought is a small one and chances of finding the sample is by traditional method is low. So one respondent being used to generate the names of others, and then the researcher will go to those names and they will give some names of others. Then this is how the researcher will collect the data. So networking process. For example, a researcher wants to study the homeless in the Texas city, and he can identify one or two individuals who are willing to participate. Now, those homeless individuals provide some details of other homeless individuals. In this manner, researcher can continue to tap many homeless, and he or she can collect the data. So this is the snowball sampling. So this is the graphical illustration. Yes. Networking means networking means suppose so that means suppose we can see from the data, suppose we can find two homeless and that two homeless individual, they are providing some information of suppose 3. So then we can go to those 6 individuals and they are also giving them names of some other 10 individuals. This is how we can go to take the sample. So that's why this is a networking process. Networking to find the respondents. Find the respondent. This is the networking, not any specific type, but it's a networking process to find the respondents, the sampling individuals. That's how snowball sampling works. Okay. Next is the graphical illustration of non-probability sampling. So we have taken the same population and we have used the non-probability sampling. So suppose for convenience sampling, suppose group D is convenient to the researcher. So he or she will select that sample, that group as a whole, and all the elements are considered as the sample. Now for the judgmental or purposive sampling, suppose the researcher, according to his or her judgment, will consider BCE group, and from some sample, from those clusters or from those groups, the sample is considered as elements are considered as sample. And quota sample similarly works as the stratified sampling. And for snowball sampling, you can see from here the first two groups, their selection, and the last three groups, their referrals. So first we select the samples from first two groups and they are referring. So first, suppose two elements, second individual, he or she is referring 12th and 13th individuals, and the ninth one referring to 18. So then 2, 9, and 12, 13, 18, these are the referral selection. Now, there is some drawback of non-probability sampling, because as this is dependent on the choice or the judgment or the convenience of the researcher, then there should be some sampling bias. And this extent of bias in selecting sample is not known. And this makes it difficult to say anything about the representativeness or the accuracy of the sample. So how to avoid the sampling bias? So basically, which is the problem of non-probability sampling, but if we want to avoid the sampling bias, so we have to define the population properly and the sampling frame. So what we can do, we just match the, if we can make the sampling frame and the population, we can match the sampling frame with the population as much as possible to reduce the risk of the sampling bias. Keep your survey length short and easily accessible. Set your survey goals. Do a follow-up on the non-responders and give the respondents a chance to participate equally. And to avoid the sampling bias, avoid using convenience sampling. Convenience sampling is not a good option to select as a sampling technique. You can use the purposive sampling for this purpose. Okay. And these are the strengths and weaknesses of the sampling techniques. Like convenience sampling, this is least expensive, least time consuming, more convenient, but there is a selection bias. Sample is not representative, so not recommended for descriptive or casual research. Judgment sampling, this is low cost, convenient, but not time consuming. And weaknesses does not allow any generalization or subjective. This is dependent on the judgment of the researcher. Quota samplings, the strength of sample can be controlled for certain characteristic, but there is also the weakness of selection bias and no assurance of representativeness. And for snowball sampling, the strength is it can estimate the rare characteristics of the population, but this is time consuming. And now if we move to the probability sampling, there is also some strengths and weaknesses. Simple random sampling is easily understandable, result is projectable, but difficult to construct the sampling frame because we need to construct the sample frame to use the simple random sampling. It's expensive, lower precision, no assurance of representativeness. And for simple systematic sampling can increase the representativeness than SRS, than the simple random sampling. So it is easy to implement this systematic sampling than the simple random sampling. Here sampling frame is not necessary always, but can decrease the representativeness depending upon order in sampling frame. Now, stratified sampling includes all important subpopulation, but this is difficult to select the relevant stratification variable. So for this problem, we have selected stratification variable as sex, but it is not always sex is the important thing. So we have to first choose the stratification variable. Otherwise, the stratified sampling is not useful. Not feasible to stratify on many variables, and this is expensive. And for cluster sampling, this is easy to implement, but difficult to compute and interpret the result. Now, depending on the strengths and weaknesses, the researcher can decide the suitable sampling technique. So the next questions comes to his or her mind, that is, what will be the sample size and how large or how small the sample should be. So there are some factors to determine the sample size. So what is the nature of the population? If the population items, those are homogeneous, then a small sample is best to serve the purpose. But if the items are very heterogeneous, they are very diverse among each other, then a large sample is needed. Number of classes proposed. If many class groups are formed, a large sample is needed. And nature of study, for technical studies, we can use a small sample, but for general service study, we need the large sample. And sampling techniques also, that the sample size is also depend on the sampling techniques. For different sampling techniques, we need the different types of sample size. And if we want to increase the standard of accuracy, we need the larger sample. And availability of finance, if we have the finances large, then we can use the large sample. If the finance is not so that we can have to use the smaller sample. Now, but we can decide the sample size depending the some formula. So sample size for known population and sample size for unknown population. If suppose the population size is known to us, so this is the formula for the sample size, where the Z is Z score, like Z 0.05 is 1.96, Z 0.01, that's 1.645. We can use the Z score number. Sigma, the population standard. Sorry. Okay. So sigma is the population standard deviation. E is the margin of error. Margin of error, basically, we use this concept for introducing the confidence interval. Suppose we say that 30% to 40% is the range of mean. So that, and 35%, suppose 35 is the mean, but we'll say that 30 to 40 can be the mean. So that 5 or that 5% or that type of thing, that is the margin of error. So that's the confidence interval using that margin of error. So N is the capital N is the population size, small n is the sample size. Now we can use these two formulas. If we know the population, then the first one. If we don't know the population size, then you can use the second one. Now for marketing research studies, I have researched on some marketing research papers and some books. Then I have found this usual sample sizes for marketing research studies. So if the study is for problem identification, then the minimum size that is needed for the study, that is 500. And problem solving research, the minimum size is 200. For product test, 200. Test marketing studies, 200. TV, radio, print, or online advertising, 150. And test market orders, 10 stores, and focus group, 6 groups. This is a table from a marketing research book I have found. And basically, when the statisticians, use some sample for some technical studies, or suppose that's just theoretical studies, but we need a real data or some secondary sample or some primary data, then that is a thumb rule that we have to use. If we want to use the large sample, then we have to use the sample size greater than 30. That is considered as a large sample. But for the marketing study, this is the minimum sizes, usual sizes that is needed. Now, after getting your sample size right, it is important to understand both sampling errors and the non-sampling errors. So first, what is sampling errors? Sampling error is basically the thing that is when this arises when the sampling is not the representative of the population. So this is basically the difference between the population parameter and the observed statistic. And the non-sampling error, this arises due to some other factors. Suppose failure to measure some data, there is a measurement error, the forming the questionnaire formation is not right, or we can say that the editing error, the coding error, these are the non-sampling error. So how can we reduce this sampling errors? So for sampling error, we can just increase the sample size. Like if we use the complete enumeration data, there is no sampling error. So if we increase the sample size, then we can reduce the sampling error. But that is not true for non-sampling error. In some cases, if we increase the sampling error, non-sampling error also increases. So to reduce the non-sampling error, which is little difficult, but we can just what we can do, we just follow up the non-responders, or we can study some mechanism design. We can carefully design the questionnaire, or we can carefully design the method. Then we can eventually reduce the non-sampling errors. So this is it for my part. And if you have any query, you can ask me about this one. So this is the basic thing about sampling, and the different types of sampling techniques, and different the sample size, or the sampling errors, non-sampling errors. So thank you so much.
If anyone has any question, they can ask, ma'am.
Yes, I think Dr. Amit Mujumdar has raised his hand. So if you have any query, you can ask me.
Amit sir is there.
Yes, I have a one question from Shonali. Yes, is there any biasness in judgmental sampling? Yes, there is a biasness in judgmental sampling too. But if we consider the convenience sampling, that is more. But for judgmental sampling, also there is some biasness. For non-probability sampling, this is the problem, that we have the sampling biasness. Judgmental sampling also, but not like the convenience sampling. So this is suggested that don't use the convenience sampling if you want to reduce the risk of the sampling bias. But yes, in judgmental sampling also there is some biasness, because that is dependent on the researcher biasness. Can you please explain the formula? Yes, of course. Yes. So this is the formula for the known and unknown population. This is basically will calculate using from the confidence interval, using the Z-score and the margin of error. So when we have the estimation of the proportion or the mean, then the formula of that confidence interval, from that we can find the sample size. So you can find the derivation from any book of that statistics, or where we can find the interval estimation or confidence interval. You can find the derivation of this. So so the first one, known population, when we have, suppose, the sampling without or without replacement, or like this, so we can use this type of population. When the population size is very known, then you can find it from any book where this is interval estimation or confidence interval is explained. So from these, we can have this type of sample size. Yes. Is there any other query? Yes. So the sampling error. Okay, I'll just open the window again. Yes. So the sampling error is basically the difference between the population parameter and the observed statistic, that is known as the sampling error. This is because sampling is used to represent the population, and using the sampling we want to estimate the population parameter using the observed statistic. But if sampling is not the representative of the population fully, so then there should be some difference between the population parameter and the statistic which we are using to estimate the population parameter. But as this is not representative, so that's why there is a difference, and that is the sampling error. There you can find some formula for sampling error, but that is the basic concept of sampling error, and that sampling error can be reduced if we increase the sample size. Then the sampling, we can avoid that sampling error. Okay. Thank you. Thank you so much.
If anyone else has any query, they can ask, ma'am. Okay, I think nobody else has any questions, ma'am. So, ma'am, I would like to thank you for conducting this session today. This will surely be very beneficial to everyone assembled here today. And once again, thank you so much for sharing your knowledge and ideas with us. Thank you so much, ma'am.
Thank you. Thank you so much. Thank you.
Okay, thank you, madam. And I request you all. Now we are moving for an evaluation test, which is scheduled at 8. So the link for that particular schedule assessment test will be shared in the WhatsApp group. I request all of you to check your WhatsApp group for that link, and you will get 45 minutes time within which you have to submit the answers. So till then, goodbye to all of you. We will again meeting at 8:45. So for the time being, we are leaving this particular platform, and I hope you enjoyed this session. So all the best for your assessment test. Thank you.